Hello, I'm Karen, and in last week's video I was sharing with you my quantum blanket and I was sharing with you the gravitational pull. And in this week what I'm going to do is I'm going to share with you the anti-gravity. So we've got my pieces and we've got some maths. So for the actual blanket we needed these pieces here, and so this was my quantum, this is my quantum bit, this is the baby bit, and this was the heart piece. And these are the opposite pieces for each one. So this is the anti-gravity, and just so that we've got the equations, one of these would need 4 of those to be able to create zero gravity. And it works the same for each piece. So this bit matches this bit matches this bit, and we've got the heart to match the heart. Okay, so they're the pieces that we're going to use, and I've actually crocheted you a quantum tunnel to be able to show you how how it all works together. Okay, so I'm just going to move these pieces out of my way for a moment. So I've got some maths for you because I know that for the physicists they'll be wanting the mathematical calculations. So the anti-quantum, so the biggest piece that we've got here is 0.000448. The next bit down, this one has got an extra 0 in it. Then we've got this one which has got 5 zeros and a 6 4, and then this one's got 7 zeros and an 8. Okay, just for that baby bit as belong to that piece there, just so you've got the actual measurements. Okay, so what I'm going to show you, so this piece here is pieces that I've joined together, and this is what I'm referring to as a quantum junction for want of a word, because it's just the easy thing. So we've actually got 3 of the actual squares and we've got 6 of the pentagons. So we've, in this situation here, for the measurements of it, 6 of the, because that these pieces measured 0.000112, so I've got the mass there to show you what 6 is. And then if you've got 3 of these pieces, and what you do is you take away the quantum from the anti-quantum and gets you the result. So this one, this piece here, is twice the strength of the actual gravitational pull. So this is a strong piece. Okay, what I'm going to do is I'm showing you the other pieces. So for this particular set we've got these pieces. So this is 4 pieces of the quantum and 1 piece of anti-quantum. So this one would be 0 gravity. And if we then added on to this piece, we add on extra pieces, we end up with, we've got now too much gravity to anti-gravity, so this one would effectively collapse. So this would be the entranceway to our tunnel. To prevent the collapse, we've got this extra piece here, which is made out of these are the quantum bits. This is the anti-quantum bit. So this one would zero these ones out, so this one would become 0, but we've got extra oomph there, so this is like its little rocket because that's more powerful, and this would go and slot into this piece here like that. And then these pieces around the edges would then have the strength of this to go with it to be able to then prevent the gravitational collapse, and this makes a nice solid structure. And what I'm going to do is show you how these pieces join together onto the actual blanket, just so that you can see how it would actually work. So let's just get that to there. So you need extra pieces. So this piece, this is my quantum overlap, so that piece would join onto that piece there. Then we would need this piece to join on to here. Is it that way around? Hang on, it's got the right way and it's wrong way. That goes that way around. Then my next piece would then join onto that way. I'm trying to make sure I'm going in the right direction because the pink pieces are on my directions there, and I want to put those there. So these bits sit there, that bit then sits to there to be able to go to there, and then these pieces, so these little pieces that I've got, will fit here and here like that. And then this piece would then join to there to be able to make its way to the other piece. So we've got this coming around. So here we've got all the strength. These bits are preventing you from being able to come down that way because they've not got the proper entrance or exit ways. So you'd go in at 0 gravity, the strength here would push you around and push you out the other side. So that's how you would move through the tunnel. And I know that was really hard to see against the blanket, so I'm just going to move those out of the way a minute. And I'll just get a different background and put that over the top just so that you can see how those pieces are actually all joining together. So this is your, oops, dropped that bit there. So that bit fits to there. This bit's going to fit over here. This is one of my junctions which needs to be that way around. There, like that. So that would go to there and to there. This junction would then fit that way around there. This is the exit point here because that's a pink piece. I've tried to colour coordinate so you can see where we're going. And then this piece would then come out there so you can see that curvature shape that we've got. Maybe if I just lifted up everything a little bit just so you can just see better there of how that's actually fitting together. Okay, so I'm just going to move these pieces completely out of my way for a minute and just bring you back all of the maths that goes with all of this. So my observations from doing all of this, I needed, so half of the actual set contained 29 pieces. There were 7 squares inside of those pieces, so the whole set made, there was 8 shapes, so it completed another cycle of the 8. I kept saying all these cycles of 8, which gives me a total of 58 pieces. 5 plus 8 is 13, and I needed 2 halves, obviously, to make it. So I noticed, my observations I noticed while doing this one is I created another set of 5 prime numbers. Now, I'd already got 3 left over from when I was doing my other set, so that made another total of 8, so I completed another cycle. And I did the experiment of doing the same thing of turning the numbers that I'd found into the relevant numbers of the periodic table. So these are the relevant numbers and the relevant atomic mass. My observations from those, I ended up, by adding those to the other ones, a total of 16 items from the actual periodic table. And 8 of those was metals and 8 of them was non-metals, so that was 2 more sets of 8. And just so that you can just do the quantum measurements, just so we can just show you the 0 gravity, I've used hydrogen. That was just because it was easier for the maths to share. So here, the atomic mass of that is 1.008. If we use the quantum measurements, it would be as follows. It will be the 1.008 divided by the number that got, which has got 5 zeros and 16, which is my quantum baby bit, divided by 7 equals the 90,000, divided by 10 equals 9,000, times that by the actual quantum measurement itself, which was the 0.000112, which gets you back to the 1.008. If we use the anti-quantum measurements, we can see the same. We start off with the measurements here, divide it by the anti-quantum measurements that I told you, divide it by 7, then times it by 10, and then times that figure by the actual whole quantum measurement, which gets you back to the same figure. So as we take, so it's the anti-quantum is minus the quantum, which would then equal 0. And just one more little bit to show you is with the hearts. So this one would represent 0. It'd have 7 zeros and an 8. This one is 0 point, and then it had 7 zeros and a 2. And if these were to put together, I know it's like a butterfly, but imagine the butterfly could go all the way back, yeah. And because this is stronger than this one, because you need 4 of these, like out of there, to equate the same value as that. But at the minute we've got an unequal value, so it would cause this butterfly effect, for want of a word, which would be going super, super fast, which would actually have a spin on it. And that's what you would see if you was looking for those bits. So there you go. There are my measurements for the anti-gravity. So we've got that and that. And I just would like to share this with the physicists. They're saying that they're looking for these figures, and it's took me 8 years to work out all of what I've worked out and shared in just my last couple of videos. So all I can do now is say thank you for watching, thank you for liking, and bye for now.